In this video, I will be installing the EDS file for Telesis lasers, be adding a laser to my project. I will import an add-on instruction to handle communications between my controller and the Merlin laser software, and then taking advantage of some of the sample logic that's been provided by Telesis. So we'll start with adding the EDS file. That's under Tools, EDS Hardware Installation Tool. Next, I will register an EDS file, register a single file, browse to my files from Telesis, and the file we want is MerlinCifxv1.4 EDS. Click Next. That looks good. Click Next. That's the icon that will be brought in with the EDS file. Next, and click Next, and finish. It usually takes a few seconds for my software to update and be ready to go again. But to add the laser, I go to my Ethernet. Right click on Ethernet, select New Module. I'm going to uncheck all the module type vendor files and scroll down to Telesis, check that. There's only one, so select the one and create. So I need to give it a name. I'm going to keep it simple, just name it laser and an IP address. My project, I want it to be 192.168.1.10. Yours most likely will be different. And I see that by default it's come up as my connection type with an FQ series laser, but I happen to be using one of the newer lasers from the SP series family, so I'll go to Change and click in this box here, drop down, and I find SP series. Leave the input and output sizes both at 128. Select OK. And then OK. And I see when I did that, I've created a couple of new module defined data types. We'll see what they look like. Laser inputs now has a data type with descriptive names for all of the elements, and likewise with the output data, descriptive names for the elements. So next I want to bring in the add-on instruction to handle communications with the Merlin software. So I go to add-on instructions here, right click and import. And I will go to my downloads where I put the files from Telesis, and I'll select from the SP folder. And it's the Telesis model F21, F22. Those are the laser controllers that are associated with the SP series lasers. And tell that to open. So this pops up. I'm just going to keep everything as defaults and click OK. So I can see now my add-on instruction is here, and along with that it brought in a couple new user-defined data types that are needed by the add-on instruction. So next I'm going to bring in sample logic routine that Telesis has provided and see what's in there. Again, I'll just follow the defaults. And I see a new UDT and a couple of new controller tags, L1 control and user. So what's in sample logic? What is it I need out of here? Well, the first 4 rungs are associated with single bits that may or may not apply to you. I would suggest reading the title comments. They explain what these bits do, and you can select the ones you want to use. I would suggest also that you always have verify message turned on. So I'm going to select that rung, copy, go to my op20 etch routine, paste it in, and I'll get rid of this there. So it just so happens in my machine, the first thing I'm going to do in my cycle is load a laser pattern. So I find the sample rungs for loading a laser pattern. There are 3 of them. I'm going to copy those, paste them into my op20 etch cycle. Then the next thing in my cycle is going to be updating some variable text in the pattern, what I want to mark on the part. So I scroll down to update variable text. And I take the 3 rungs again associated with updating variable text, copy those, and paste them into my op20 etch routine. And for my op20 etch cycle, after I update the variable text, I just want to go ahead and print. So this sample logic routine has all of the different message types available in it. So I'm going to scroll down until I find start printing. So there's a rung associated with printing. That one's associated with printing. This one is also. And that one, are there any more? No. The next one is get laser name. So it's those 4 rungs. Copy. Go to my op20 etch and paste those in. Now I need to go through and change this user tag to a tag that is more appropriate for my machine. So I'm going to double click there. I happen to have one set up for my op20 cycle, and that's the verify on bit. I'm going to set that to be true because I want that to always be on. I always want the verify message. And then this run, there's a user tag, so I'm just going to drag that guy down there. That's my auto cycle or in cycle bit. And then this is my user.load pattern. Replace that with my op20 cycle load pattern. And this is the load pattern pass, so I'll replace that with op20 cycle load pattern pass and load pattern fail. And then I see over here I have a user tag element for my pattern name, so I happen to have an op20 cycle pattern name right here. And I see that that is of data type string, and I'm copying it to a data type string so they match. That's important. And then there's a user cycle complete. So just to start with, I'll grab that. And my op20 cycle complete. And then there's my load pattern pass. So I already have that here. I drag it, and there's another one here. And then load pattern fail. So 20 cycle load pattern fail. And op 20 cycle load pattern fail goes here. 20 cycle complete. And then I have this fault reset bit in here. You can have that or not. It's up to you. Pattern fail reset. I think those are taken care of. So the next rung is my in cycle bit, and I want to update variable text as soon as my pattern has been successfully loaded. So I'm going to drag that there. So I'm in cycle, my load pattern is passed. I want to update my marking data. So that's send data pass. This one here will be send data fail. There's a user tag element. That's my data I want to use to update with. 20 cycle variable data. And that variable data could very well say come from the tester. And that's a string type, and it's getting copied to a string type. That's good. And also, when I update variable text, I have to indicate to the laser, to Merlin, what line number that variable text field is on in the laser pattern. I try to always use line 1. There are reasons why. We won't get into that now, but that's always good practice. Keep that on line 1. And so we go down to the next rung. So we have cycle complete. There. My send data pass will go here and here. And cycle complete. Send data fail. There. And there. And my send data fail reset happens to be that bit there. And then as soon as I have successfully loaded the data to print, I am going to start print. Now, just for illustration purposes, I'm going to add a bit here. Cycle. All conditions ready for print. Your doors are closed, the part's in position. You've done everything up to now is okay. I can go ahead and start the print. Now, there are two different ways to initiate a print cycle. One is to send an actual go message, or the other way is to just use a discrete bit, the start print bit. I prefer to use the start print bit. They both do the same thing. It's just a little, the start print bit is just a little more clean. So I'm going to delete the send go, and now I don't need that selection bit anymore, and I don't need anything associated with the send go command. So I can get rid of send go here, and I'll replace this user tag element with my op20 cycle printing. And this bit here, continue after pause. There are times when in the middle of your laser pattern you want to pause and to do something like, say, evaluate a data matrix code that's just been printed, and to then decide what to do after you come out from the pause. Well, we don't have that, and I'm not in this situation, so I could just get rid of that rung. But that's what the continue after pause is for. And we'll go down to this rung. See, I could get rid of the send.go references. Have my cycle complete, so I'll replace that with the op20 cycle complete. And print done, so it'll be op20 cycle print complete. And then what happens after this is just all depends on what you're doing in your machine. So all I need to do now is add the add-on instruction. There it is. So I'm going to call this op20, say SP. And have to create that tag. So there, that looks good. And my control tag is going to be L1 control. Laser in is going to be laser :I. Laser out, be laser :O. And the module, of course, is laser. So now I'm done with using the sample logic. But let's take a look at that real quick and see this show. So most messages are comprised of 3 rungs, and they all follow pretty much the same format. You need to have message idle, needs to be high before you can trigger the next message. Now what happens is as soon as you trigger a message, message idle, of course, is going to go low, but we want to keep that trigger high, so we just branch around with the triggered bit. So as long as that trigger is high, we will get either a message pass or a message fail come back. We'll process those bits and then proceed as necessary. As soon as we process as soon as we get either a pass or a fail, the trigger bit will go low, message idle will go high again, and we can move on to the next message. But I'm done with sample logic, so I'm going to right click on it and just get rid of it. The other thing I can do now is go to edit tags. I don't need this user tag anymore. It's done. And I'm not real happy with the name L1 control for this tag. I'd rather have it something else. So I'm going to call it op20 laser control. And if I go back to my etch routine, when I deleted the user tag, I deleted this element. So that's going to be op20 print done. 20 cycle print complete. Go up through and look for any more red rungs. I don't see any. Should all be good. Since I've deleted the user tag, I don't need this tsample UDT anymore, so I can get rid of that. We'll do a save, verify, no errors, no warnings. So I've added the EDS file for the Telesis lasers. I've imported the Telesis add-on instruction for communications with the Merlin software. I've used what I need from Telesis sample logic, and I've added the add-on instruction. to my routine.